Operating a bike-sharing network is a high-stakes optimization problem, balancing station demand, vehicle distribution, and workforce allocation, while accounting for variables such as traffic condition, road closures, and personnel. Small inefficiencies can quickly cascade into empty stations across the city, delayed servicing, and degraded user experience across the entire network. In partnership with Bixi Montreal, we developed Velosim, an open-source simulation engine designed to model how a bike-sharing network responds to tasks dispatching across a city in real time. Let me show you how it works. Everything starts with a scenario. Here we define the full operational context of the system, including vehicle distribution, station locations, driver availability, and real-world traffic conditions, all of which influence how decisions are made during the simulation. We can add a resource either by directly editing the JSON for quick, precise changes, or by using the interface to add vehicles, stations, and drivers more interactively. For example, I'll add a station at Concordia Metro using these coordinates, and initialize the task count to 2. Once the scenario is configured, we can then save and overwrite our current scenario. Now we can start the simulation. At a high level, this map shows the current state of the simulation, including clusters, stations, and drivers. These large circles represent clusters of stations. The number indicates how many tasks exist within the shown perimeter. If I click on one, it zooms in and reveals the individual stations present in that cluster. From here, I can select the station and assign its tasks to a driver, who will then begin servicing them. Another useful feature is that we can bulk assign tasks from a cluster to a single driver, allowing us to efficiently handle demand across a given area. To give you a feel of how the simulation works, I'll assign tasks across multiple drivers just as an operator would. If the simulation is running too slowly, we can adjust the speed using the control panel in the top right. I'll increase it to 4 times so we can observe the system behavior more quickly. When selecting a driver, we can visualize the route they are currently taking. Along the route, traffic conditions are displayed in green, yellow, or red, highlighting congested segments that may slow the driver down. This traffic data is modeled using a dataset from Montreal, but the system is designed in a modular way that can be adapted for any city. For drivers assigned multiple tasks, the next station in the route is shown in a solid color, while the route of the remaining tasks are displayed with reduced opacity to indicate their order in queue. If we want to change the order of the tasks, we can simply just drag and reorder them. The route is then automatically recalculated and adjusted accordingly. Additionally, we can group tasks by station using the arrows, making it easier to organize and manage workloads. If we look on the right, we can see the state of each driver and notice how they are color-coded for clarity. These states reflect what each driver is currently doing, whether they're idle, en route, servicing, restocking, or on break. If we continue down, we can see the total number of vehicles available at the headquarters. If we expand this section, it shows which drivers are starting their shift and exactly in how long. Below that, we have live reporting for the simulation. These metrics provide a real-time insight into the dispatch strategy's performance, including servicing to driving ratio, vehicle utilization, average total distance traveled by the vehicles, and many more. Since simulations can take a long time to complete and visualize, we provide the ability to pause and resume them at any time. You can pause the simulation and navigate away from the page, and the state of the simulation is saved upon disconnection. When you return either a few hours or a few days later, the simulation can be restored and continued exactly where it left off. To resume a simulation, you simply go to the simulations page, where you can view your simulation history along with the reporting metrics. From there, selecting Resume will restore the simulation and allow you to continue seamlessly. Finally, the application supports both English and French. Operators can switch between the languages through their preferences, allowing for seamless bilingual usage. Overall, the simulation platform provides companies with a powerful tool to visualize their operations, test their different strategies, and make data-driven decisions. I hope you enjoyed the demo, and the entire team of Velosim thanks you.